Through this question, you will be able to see why we transmit electricity at very high voltages. When we use very low transmission voltage across the power line, it will result in very high current and therefore very high heating effect and energy loss due to heat in the wires will be humongous, and we don't want that to happen. So this in part A, we are to first calculate the current in the cables. In this first scenario in part A, we are transmitting the power at 25 kilovolts across the power lines, and this is a very huge, very high voltage, which is ideal. So using P equals IV, V being a very high 25,000 volts, and input power is 120 kilowatts, we get current to be 4.8 amperes, pretty low. So next up, in part 2, using Ohm's law, we can calculate the PD across the cables. We know the current flowing through is 4.8 amperes. The resistance across the wires 30 kilometers long, and each kilometer is 4 ohm. We can get a voltage of 576 volts. And the power loss, we can immediately use I square R to find power, or P equals IV. Either way, we get the answer of 2760 watts. Now, if we send the same power at 4000 volts instead of 20 over 1000 volts, then using the same method, P equals IV, now with a much smaller voltage here, the transmission current is 30 amperes, much higher. And when we do I square R to find the power loss in the wires, we will get a humongous value over here, 108,000 watts, 108,000 watts. So therefore, power transmission is always better at higher voltages because it will lead to lesser power loss due to the heating effect of the current.